Hey everyone, welcome to another session of Razzle Dazzle Physics. In today's session, we'll be talking about the concept of nuclear fission, guys. Before we get going, guys, make sure you hit the like and subscribe button to keep my channel going and keep my content completely free. Okay, so previously in the nuclear physics topic, we've been talking about the nucleus of an atom. So here, actually on the left-hand side, you will see I've got a nucleus of an atom. As you can see, I've got some protons and neutrons here in the nucleus. So let's label one of them as the proton, and let's just say the red ones are going to be the neutrons over here. But today we're going to talk about what happens when the nucleus of an atom becomes unstable. So today we're going to be talking about what happens when the nucleus of an atom becomes unstable. So here right now we can say that, let's say that the nucleus is stable right now. But let's talk about a scenario when it could become unstable. So how would it become unstable? Well, think about this. Imagine you are the nucleus and you're carrying loads of things, yeah? Let's say you've got loads of things in your hands. What happens when you try and carry more things? So imagine like somebody gives you more stuff to hold. What's going to happen to you? Well, obviously you can't exactly hold everything. So what's going to happen is you will become unstable and you will break down, and obviously you will drop everything that you're holding. Well, the same principle applies in nuclear physics. So from here we have our atom, but let's say it becomes too heavy. So I'm just going to make it too heavy right now. So let's say there's loads of them, loads right now. All right, so as you can see right now, guys, it's become very heavy. So here it's very heavy. Now, what happens is the nucleus will become unstable, carrying too much. What will happen is it will break down. So I'm going to draw it being broken down, so it will split. So we're going to split it, and it will become two smaller nuclei. So there we go, it's smaller right now. So look, it's the splitting that we're looking at over here. So it's heavy at the start, and then it will split over here. So as it splits down, obviously, this is going to be what the topic we're talking about, which is going to be nuclear fission, guys. So this is nuclear fission. Nuclear fission is the process in which a large nucleus splits into two smaller, lighter nuclei. And the reason why you're doing this is because it will release energy, guys. It will release energy. So I haven't drawn it here, but look, the energy is going to come out as well. So here, this bit over here, energy is released. So in this case, energy is released as well in this process. So obviously this happens in nuclear fission, guys. So that is the process of nuclear fission. Okay, and also, guys, sometimes you might see it being described as the parent nucleus, it's the parent, and these two things which come off are going to be the daughter nuclei. It's the daughter nuclei. Obviously because they come from the parent. So nuclear fission, we've now defined it and we can move on, guys. Okay, so moving on from here, now we're going to talk about how can we trigger a nucleus to decay. So how exactly can we cause a nucleus to decay when it's stable? So let's say right now we have a nucleus and it is stable right now. How could I make it break apart? What could I do to it? Well, the key thing is actually about the nucleus itself. Look carefully. Let's say we were to take a neutron. So we're going to take one neutron. So here we go. Here's my one neutron over here. And we're going to fire it into the nucleus. Okay, so our neutron goes into the nucleus right now. And it will become, so I'm going to draw it over here. There we go. So there we go, guys. We can take the neutron, fire it into the stable nucleus. And what's going to happen is, look, right now we have an extra neutron right now. It now becomes unstable. So now it is unstable, because you have now added an extra neutron. It's like too heavy, so it's too heavy right now. And obviously from here, it will then break down here. So the key thing is you can cause a nucleus to break down by firing in a neutron. This process is called induced fission, guys. So this is called induced fission. So there we go, induced fission. When you use a neutron to cause a nucleus to split, guys. So you had the nucleus there, it was stable, you fire a neutron in, it goes inside and obviously becomes unstable, and then it will split into two lighter daughter nuclei and energy is released. So this is called induced fission, and it's all in part in the nuclear decay topic. Obviously, we're going to be using this to describe how nuclear power works and obviously how bombs work as well. So the key thing is to be talking about this in terms of nuclear reactors. So in a nuclear reactor, we have two types of fuel. which are going to be used. The main two types of fuel we're going to be using are going to be uranium and plutonium. So let's put that down. So there we go, guys. I put at the bottom uranium and plutonium. These are the nuclear fuels, guys, used in nuclear reactors. Okay, so we've talked about fission, which is the splitting of the nucleus. We've talked about induced fission and when you trigger it to split. And now we're going to talk about, in a nuclear reactor, what is actually happening. So in a nuclear reactor, there is a certain equation you've got to know. Okay, so in a nuclear reactor, guys, we have induced fission of uranium. So look, I've drawn it over here. On the left-hand side, you'll see I have one neutron, and we're going to fire it into the uranium nucleus, guys. I'm going to put the uranium, we're going to put the number uranium, oh, let's change the color of the pen. Let's put it as uranium-235. It goes into it, so one neutron goes in. And obviously, if you gain a neutron, the mass number goes up by 1. And obviously, we go from uranium-235 to uranium-236 for a brief period of time. But you know it is now unstable. So obviously, this is unstable. It will then break down. It will then break down and split. And there we go. Here's our split. You can see we get the daughter nuclei. Krypton comes out. So let's put that down, which stands for Krypton. And we also get barium, and we also have 3 neutrons which pop out. 1, 2, 3. 3 neutrons pop out here. And that is really important because if you're ever asked about what happens for induced fission of uranium, you've got to talk about the 3 neutrons being released as well. And also alongside this, you also have obviously plus the energy released when you actually split the uranium. So the energy is released as well. So there's my energy as well. So make sure that you're happy with this nuclear decay equation, yes? So the neutron goes into the uranium, it then becomes unstable, uranium-236, it splits to become krypton, barium, and 3 neutrons are released. And you get energy also in this process. Easy stuff, guys. Okay, so we're done with another session. Let's have a quick recap right from the top to summarize what we have learnt so far. Alright, so at the start we talked about having a nucleus which is stable, okay? So a nucleus which is stable. But we then said sometimes a nucleus can become unstable, usually when they become too heavy. When they become unstable, the large nucleus can split into 2 lighter nucleuses, and this process is called nuclear fission. Obviously, energy is released also. And as you can see on the diagram, I've got the stable part here. It then becomes unstable, guys. It's moving around. Then it breaks down into 2 daughter nuclei, which are lighter than the original. And obviously the splitting process, energy is released, guys. That's the whole point. You're going to split it and the energy is what we're going to be using later on for useful purposes. So that is nuclear fission. Scrolling down, we then talked about how we can actually trigger a nucleus to decay. So guys, we can take the nucleus and it might be a bit stable, but you can trigger it by firing a neutron into it. It will go inside it, it will become unstable and it will split and obviously release energy. This process, when you cause it to happen, is called induced fission because you are triggering it. So think about you triggering that process here. There are 2 types of nuclear fuel. They are going to be uranium and plutonium, guys, so put that into your mind also. Scrolling down, we then talked about in a nuclear reactor, the process taking place. And in a nuclear reactor, we have the uranium, and what they do is they fire the neutron into it, and as you can see, it becomes unstable, uranium-236. It splits to become krypton, barium, and 3 neutrons are released also, and energy comes out as well. This actual equation is really important, so don't forget this whenever you're describing the nuclear fission process within a reactor, guys. So the krypton comes out, barium comes out, and the 3 neutrons come out, and the energy comes out as well. Right, so that's it for another session of Razzle Dazzle Physics. Make sure you hit the like, subscribe button to keep my channel going, and good luck with your studies. And joke of the day, what do physicists have for dinner? Fission chips. Goodbye.